Hi there and welcome to today's class. For today's class, we're looking at the JAMB past question review on chemistry. So let's call this JAMB revision. For this JAMB revision. Alright, so I'll be taking up some few questions on JAMB chemistry and we're solving together. The first one here says, if the vapor density of an organic compound is 78, calculate its molecular formula. Alright, so for here, solution to this question here, I'm given vapor density, let me call this VD as equal to 78. I'm asked to find the molecular formula. Now, here's what to note. Note that molecular formula is equal to 2 times vapor density. That's it. That becomes equal to 2 times 78, and that's equal to 156. Molecular formula should be in gram per mole. So I have 256 gram per mole as the molecular formula. So my option will now be, I will take each of the options. My options here, let me say this. A, you have C8H6. B, you have C15H30. C, you have C10H24. And D, you have C11H24. Alright, so how do I get the correct answer? Your concept will be, first of all, you are given vapor density as 78. And I said the molecular formula is simply twice the vapor density. So when I do 2 times 78, I have 156 gram per mole as my answer. So the concept will now be, we'll look for the molar mass of each of these and see which of them gives us 156. So I'm taking them randomly. Don't forget, carbon, the atomic mass of carbon is 12, and for hydrogen, the atomic mass is 1. So let's start with which of them? Let's start with option B. So for B, if I take C15H30, I will use this to calculate the molecular mass and see if I have this value. So starting with carbon, it will be 15 times the molar mass of carbon, which is 12. Plus for hydrogen 1 and the number of atoms 30. So I have this as equal to, so I have 15 times 12, which gives you 180 plus 1 times 30 is 30, and this gives you 210 gram per mole, which is not my answer. So the answer is not B. Let's try D. So for D, let's say I have C11H24. Let's see how this works. Okay. So for this, let's get the molar mass of this compound here. All right. So for this compound here, C11, I have for carbon, the atomic mass is 12 times I have 11 atoms. So 11 plus for hydrogen, the atomic mass is 1 times I have 24 atoms. So I have 24. So this is equal to, if I sum this up, 12 times 11 I have 132 plus 1 times 24 I have 24. If I combine this, 132 plus 24 I have 156 gram per mole. So observe that the one that matches this value is option D. So in this case, option D is my correct answer. So that's how you solve this question. Simply multiply vapor density by 2 and then look for which of these options, where if I calculate the molecular mass, I'll have the same answer. So my answer is option D. Let's try another question. Alright, so let's look at another question here. This question here says, what is the oxidation number of sulfur in sulfur tetraoxosulfate 6? Alright, so you're asked to find the oxidation number of sulfur in this compound here. So you have your options there. Let me write the options there. So A, you have here is -4, B, you have B as minus 2, C, you have C as plus 4, and then D, you have D as plus 6. So for this case here, what is the oxidation number of sulfur? Okay, so let's get this done. Solution. So I have this case here. Right, for sulfur, of course, we'll call this X. But before then, the issue here would be for iron here. What is the oxidation number of iron in this case? Because we know that for iron has two oxidation numbers. We have iron Fe2 plus and iron 3 ion, right? So you have iron 2 ion, which is Fe2 plus, and you have iron 3 ion, Fe3 plus. The question will now be for this compound here, the oxidation state of iron, is it plus 2 or plus 3? And how do we know that? Very simple. First things first. So here's your technique. Shift these two. Let's say I have iron here plus tetraoxysulfate 6. Now I know fully well that for tetraoxysulfate 6, the ion of this man is 2 minus. So the question is this: which of these two ions will I combine with this to get this answer? Let's start with the first one, 2 plus. Let's say it's 2 plus. If it's 2 plus, what do I get? First things first, we say two ions can only combine if they have opposite charges, because unlike charges attract. Since these two are opposite charges, they can attract. So it becomes FeSO4. Now when they attract, their powers come down here. So I have 2 here. So it becomes 2 here. Also, this 2 comes down this way. So it becomes all of these 2. So I have this. In a case where the powers are the same, like this, they can cancel out. So when they cancel out, I'll now have FeSO4, which is what I have here. That means in this case, the ion I have is iron 2 plus. What if it was iron 3? What would we expect? If it was iron 3, I would expect something that looks like Fe3 plus SO4 2 minus. For iron 3, 2 comes this way, so I'll have Fe2, 3 goes this way, so it becomes SO4. This 3 comes here, becomes 3. So you have Fe2, SO4, all in bracket 3. Observe that 2 cannot cancel 3, since they are not the same thing. Alright, so I'm using iron 2. So let's get the oxidation number of sulfur here. So it becomes F. So we've established that this is iron 2. Now have that for iron, we've established that it's iron 2 plus. So plus 2 plus for sulfur, we don't know, so we'll call it X. Plus for oxygen, the oxidation number is minus 2. It's a constant for oxygen, times 4 is equal to, for a compound such as this, which is a neutral compound, which means this compound does not have any charge here. There's no plus or minus here. You equate it to 0. That's how you do this, please. So assuming this compound had a charge, let's say plus something or minus something, you equate to that thing there. But since there's nothing here, it becomes equal to 0. What condition do you have here? This gives you 2 plus X plus minus 2 times 4 is minus 8 is equal to 0. Okay? So what's the next thing here? This is 2 plus X plus minus is minus 8 equal to 0. So take the numbers together. 2 minus 8 is minus 6. Then this one here plus X equal to 0. Move this man over here. So X is equal to minus 6 comes and becomes plus 6. So the answer here is plus 6. That's your answer. Now let me give you an expo. Always remember this. A tetraoxosulfate is usually 6. It's mostly 6, except in few cases. So if you have a case where you don't have time, you have to just speak very fast. Always remember that a tetraoxosulfate in a basic form is usually 6. So you can see here. Also, note that a trioxocarbonate, example this, right, for a trioxocarbonate, the oxidation number is usually 4, all right? So trioxocarbonate is usually 4 plus 4, while a tetraoxosulfate is usually what there? Plus 6. So I think you should have this one at the tip of your finger before we proceed. All right, let's take yet another question. All right, so let's try yet another question. This one here says, calculate the percentage composition of oxygen in calcium trioxocarbonate 4. Right. Um, Solution there. We are given the following. We are given the atomic mass of calcium as 40. We are given for carbon as 12. We are given for oxygen as 16. Right. We have to find the percentage composition of oxygen in this. So how do you find this? Now, your first task would be to get the correct formula of the compound. So when you have calcium trioxocarbonate 4, your compound, this is how I showed you earlier, should be this. All right. So this is the compound called calcium trioxocarbonate 4. This is the first task. Now, your next task is to note this. Note that for this, that the percentage composition of the element, in this case oxygen, is equal to mass of oxygen, that's the mass of the element, mass of, in this case the element is oxygen. Now observe that oxygen here has 3 atoms, it becomes times 3 all over the molar mass of the compound, molar mass of compound, of course, times 100%. So this times 100%. All right. So let's get each of this. Let's start with the first one there. Mass of oxygen. I think that's mass of oxygen is simply equal to, for oxygen, the atomic mass is 16 times, we said 3, because it has 3 atoms here. So 3 all over molar mass of the compound. The compound is carbon. For carbon, I have 40. That's for carbon, plus calcium. This is for all over. For the compound, the first I have is calcium. For calcium, the atomic mass is 40. So I have 40 plus, I have carbon. For carbon, atomic mass is 12 plus oxygen. Oxygen atomic mass is 16, of course, times 3. So this is how you find this one here, times 100%. So I have this. All right, so we'll solve this simple maths and see our answer. So 16 times 3, that should be about 48 all over. This is 40 plus this is 12 plus this is 48 times 100%. All right, bring in values. If I bring in values, so this is equal to, can you write it here? 48 all over. Let's look at, that should be a 100. Yep. 40 plus 12, that's about 52 plus 48, that's like 100. If I add all of this, I have 100 times 100%. From here, 100 cancels 100, and that's equal to 48%. So the answer there is 48%. Let's see the option that matches 48%. What I have here, the option that matches 48% is option B, 48%. That's how we solve this question. All right, let's see another question. All right, let's see this other question. This one here says, for a general equation of the nature, this, he said, the expression for the equilibrium constant is dash. So we asked to find expression for equilibrium constant. We dealt with this concept of equilibrium constant in our previous class, and we said equilibrium constant K is given by the ratio of the concentration of the product. So we said this all over the concentration of the reactants always to their various power depending on what the power is. So this is how we get equilibrium constant. We said this means what there? Concentration. So if this is true, that means in this case we'll have that the equilibrium constant is equal to, if I look at the product, I have these two as the product, so it becomes R as my product. I'll put it in a square bracket showing concentration. This square bracket shows concentration of the reactants to power M, right? The coefficient becomes your power here into concentration of the next one here, S, to this one as a power N all over. Now come to these are the products, come to your reactant, it becomes concentration of the first reactant is P, I have this, and the power here is X multiplying, you can put dot here to show multiplication, multiplied by Q, this to the power Y. So I have this. Alright, so if I have this here, that's my answer. The option that matches this should be option C. So option C is the correct answer. That's the correct answer there. Alright, so that's how you solve these questions. Okay? Let's look at a next question. Alright, so the next question here says 300 cm cube of a gas has a pressure of 800 millimeter mercury. If the pressure is reduced to 650 millimeter mercury, find its volume. Right. So if I look at this question contains volume and pressure, volume and pressure. And if that's true, what comes to mind is Boyle's law. Because from Boyle's law, we have that from Boyle's law, in mathematical form, we have that P1 V1 is equal to P2 V2. Alright, so they said the first thing that was mentioned there is 300 cm cube. That's V1 is equal to 300 cm cube. Okay, has a pressure P as, or P1 as 800 millimeter mercury. Okay, they said if the pressure is reduced to, so P2 reduced to, the value here is 650 millimeter mercury. They said we should find its volume. So V2 is equal to unknown. The first task would be, I'm seeing cm cube here, I'm seeing millimeter. Do I have to convert? In this case, you don't really have to convert because the units will cancel out. So you don't have to convert. So if I use P1 V1 equal to P2 V2, I have P1, which is 800, into V1, which is 300, is equal to P2. P2 is 650 into V2. V2 is unknown. I'll call this V2. Alright. So multiply this. What do you have? It means that to get V2, I'll divide here by 650. Divide here by 650, such that this cancels this. I will now have that V2 is equal to 800 times 300. Let me see this. That's 800 times 300 all over 650. That's about 369.23. Don't forget the volume was in cm cube. So cm cube. So let me check which option rhymes with this. Which option rhymes with this? 369.23. That is option B. So option B, so you can see, is your correct answer. Alright, so option B is your correct answer. Let's try another question. Alright, this question says the type of isomerism shown by cis and trans isomer is very simple there. This is under organic chemistry. The answer is there is geometrical isomerism, right? So under geometrical isomerism, you now have the concept of cis and trans system, right? You can check out my video on organic chemistry so that you can learn more about that. All right, so let's move on to the next question there. Next question here says the oxidation state of carbon in this HCOOH. You're asked to find the oxidation state of carbon here. So what will it be? Simple. So we would call carbon unknown. We know that for hydrogen, the oxidation state of hydrogen here is +1. Plus for carbon, it's unknown. We call it X. Plus for oxygen, it's always -2. Plus, okay, it's -2. For oxygen here, also -2. Plus for hydrogen, we just said for hydrogen there that the oxidation state of hydrogen is +1. So +1 is equal to 0. So we have this. All right, it's equal to 0 because this is a neutral compound. There's no charge here, plus or minus. So it's neutral, so it becomes equal to 0. So work this out and find the value of x. This becomes 1 plus, this becomes x. Plus -2 is -2. Plus -2 is -2. Plus is plus. Bring down 1 equal to 0. All right, so I have 1 plus x. -2 is -4. -4 plus 1 is -3 equal to 0. So I'm having 1 minus 3, that's -2 plus x equal to 0. Move this man over here, you have that x is equal to 2 or perhaps +2. So the answer here is +2, which is option B. So option B is your correct answer, +2. Okay, so having said that, let's try like 2 more questions and then we're done with this revision. So let's try 2 more questions. All right, so let's look at this question here. This question here says calculate the number of moles of HCl, that's hydrochloric acid, present in 20 cm cube of a 0.75 molar solution of the acid. All right, so you have your options there. I'll just go through the list now giving parameters. The first one I'm giving there is volume V as equal to 20 cm cube. The second thing I have there is that I'm giving the molarity or the concentration as 0.75 molar. I have this. I'm asked to find number of moles, N is equal to this. So this question is under a concept called molarity. Right? Molarity, that's M, is simply equal to number of moles, so number of moles all over volume. All right, so here's something to note. The volume should be in dm cube, which is decimeter cube, and the reason is because of this. Molarity M is measured in 0.75 m. This m here is called molar, and 1 molar is equal to 1 mole per dm cube. So that means that your volume should be in dm cube. I'm giving volume here in cm cube. What do I do? Very simple. To convert from cm cube to dm cube, simply divide the cm cube by 1000. So please take note, please. That means my volume V is equal to 20 over 1000 to give me my answer in dm cube. And this will be about 0.02 in dm cube. So I have 0.02 dm cube. So I have successfully converted my volume to dm cube. All right, getting out my, so if this is correct, what's next in there? Next, we'll have to put in these values into a formula. And if you do that, we now have that the molarity, which is 0.75 molar, is equal to number of moles. Let's call this N all over the volume, which is 0.02. This is all over 1. So if I cross multiply, N times 1, N is equal to this times this, 0.02 times 0.75. If I multiply this, I have this times 0.05. My answer here is 0.015 moles. We have to find the number of moles. So my answer is 0.015 moles. I will check which option matches this. The option that matches this is option A. My answer there is option A, 0.015 moles. So that's how we solve this. All right, let's take a final question for today's JAMB revision. Then look at something else. All right, let's try one more question for our final revision. This question here says, how many unpaired electrons are in the p orbital of a fluorine atom? So what do we know? First things first. We know that this question is from the SPDF configuration of electrons. Now, for S, the maximum number of electrons is 2 because it has just one shell, or one shell. For P, the maximum number of electrons here is 6. For D, the maximum number of electrons for D is 10. For F, maximum number of electrons is 14. So I have 2, 6, 10, 14. That's the first case. This P has just one box, which is this, or one orbital. Just one orbital here. P contains 3 orbitals, something that looks like this, this. Okay. D contains 5 orbitals, something that looks like this. So 1, 2, 3, 4, 5. This one contains 7. But then back to my question here. Also, the element given here is fluorine, and for fluorine, the atomic number of fluorine is 9. All right, so I'm going to put 9 under the SPDF configuration. All right, so with this concept, let's go back to our SPDF configuration. I have 1s, 2s, 2p, 3s, 3p, 3d. This should do. Don't forget that when it comes to our order, 1s comes first, and then 2s, and then this one here. So in order of priority, I'll have 1s first, and then this one here, 2s, and then this one here, which is 2p, and then 3s. All right, with this concept like here, let's see how we can fix this man in. The first one I have there is 1s. So if I have 1s there, I have 1s. Okay, let me use orbital diagrams instead. So for 1s, I have my box like this. I will call this 1s. We said s has just one orbital. So we'll fix in, this can contain 2 maximum electrons, one going up and one coming down. So I'm done with 1s. The next one there is 2s. So I'll have this one here. So I'm having 2s. For 2s again, I'll try to fix in my number of electrons that are left. Now I took 2 from here. I had 9 electrons for fluorine. I've taken 2, so I'm left with 7. Out of that 7, this is still an s orbital, so it can contain just 2 maximum. I'll fix in 1 and 2 again. So far so good. I've fixed in 1, 2, 3, 4. I've fixed in 4 electrons out of a possible 9. That means I'm still left with what there? 5 electrons. After 2s, the next one here is 2p, and we said p has what there? 3 orbital spaces. So I'm having this one here and this one here. Okay, I'm calling this 2p. Okay, so I can call this 1s squared if I want to. 2s squared. Therefore 2p, I have 3 spaces left. Now the rule here is that you must fill in the ones going up first before you fill in the ones coming down. I'm already filled in 1, 2, 3, 4 out of 9, so I'm left with 5 more. So the rule is that take the upper ones first. So if I count here, 1, 2, 3, 4, 5, 6, 7. So observe, I fill the ones going up first. Then I'll come back and fill the ones going down. 7, 8, and then 9. At this point, I've filled in my 9 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, so the question here, going back to my question, the question here was to find how many unpaired electrons are in the p orbital of a fluorine. So if I look at this, the number of unpaired, this is the only unpaired electron here. So hence, the number of unpaired electron here is just this one here, which is 1. So this is 2p, 1, 2, 3, 4, 5, 2p, 5, by the way. So the number of unpaired electron is just 1. So the answer is A, 1. So I have just 1 unpaired electrons. Alright, so this is how we solve this question. Alright, so this is as much question as you can take into this class. Alright, if you enjoyed this video, don't forget to hit the like button, and of course, if you've not subscribed, subscribe to this channel. Also, don't forget to leave a comment of the topics you want us to treat. Alright, if there's any topic you want to treat, leave the topic in the comment section and we'll get to it. Also, I've prepared over 100 courses on mathematics, physics, chemistry, and other science subjects on my website. Right, so you can visit my website there, www.jonahimani.com/courses, and then you see the JAMB/WAEC courses. It gives you a lifetime access to over 100 of these courses. All right, so if you're interested, you get the course there and then learn with that. All right, thank you very much, and see you in the next class.